Let us consider the particle in a box in 3 dimensions. Let us consider the x-axis. The two boundaries in the x-axis are x is equal to 0 and x is equal to L. When x is equal to 0, the value of the wave function psi equal to 0. When x is equal to L, also psi is equal to 0. Because of the boundaries, we cannot find the particle. The other axis is y-axis. The two boundaries are y is equal to 0 and y is equal to L. When y is equal to 0, psi is equal to 0. When y is equal to L, psi is equal to 0. Because of the boundaries, we cannot find the particle. And similarly, we have the third axis, z axis, and it will have two boundaries. One is z is equal to 0, psi is equal to 0, and the other is z is equal to L, psi is equal to 0. In between, the particle keeps moving, and since you can find the particle in between, the value of psi is not equal to 0. So we have three sets of boundary conditions. One is with regard to x, the other is with regard to y, and the third one is with regard to z. Now, since the particle is moving, value of potential energy will be 0. The total energy will be equal to sum of the potential energy and kinetic energy. And since the potential energy is 0, the value of kinetic energy is half mv square, which is mv square by 2. And so the value of total energy is mv square by 2. The total energy is equal to mv square by 2. Multiply the numerator and denominator by small m. We will get m square v square by 2m. It will be mv the whole square by 2m. The product of m and v is the linear momentum p. Substituting product of m and v as p, we get p square by 2m. So the total energy will be equal to p square by 2m. Now consider the Hamiltonian operator, which is the total energy operator. Since the total energy is p square by 2m, the total energy operator will be p hat square by 2m, where p hat is the angular momentum operator given by h by 2 pi I dou by dou x plus dou by dou y plus dou by dou z. Since we are considering the particle in 3 dimensions, we get 3 terms, differential terms. Now taking the square of this linear momentum operator, we get p hat square is equal to h square by 4 pi square I square dou square by dou a square, dou square by dou e square, dou square by dou z square, and I square is equal to minus 1, and so we'll get p hat square equal to s square minus s square by 4 pi I square dou square by dou a square plus dou square by dou e square plus dou square by dou z square. Substituting this value of p hat square and the expression for the Hamiltonian operator, we will get value of Hamiltonian operator equal to minus s square by 8 pi square m dou square by dou a square plus dou square by dou e square plus dou square by dou z square, and this will be the value of Hamiltonian operator for the particle in a box in 3 dimensions. Consider Schrodinger equation is psi equal to E psi. Substitute the value of Hamiltonian given by equation 9. This is value of Hamiltonian h is equal to minus s square by 8 pi square m into dou square by dou a square plus dou square by dou e square plus dou square by dou z square. So this is the Schrodinger equation for the particle box in 3 dimensions. Split the terms on the left hand side, we will get minus s square by 8 pi square m dou square psi by dou a square minus s square by 8 pi square m dou square psi by dou e square minus s square by 8 pi square m dou square psi by dou z square. Here the value of wave function psi depends upon capital X as small x, y and z. X, y and z. Psi depends on x, y and z. So all the three terms on the left hand side depends upon the three variables x, y and z, and our aim is to change it into three terms, one term depending exclusively on x, the other term depending only on y, the third term depending only on z, and for that we make use of variable and separable method. In this we substitute the psi, which depends upon three variables x, y and z, as a product of three functions. One is capital X, which depends only on small x. The other is capital Y, which depends only on the variable small y. The third function is capital Z, which depends only on the variable small z. In short, psi will be a product of three functions: capital X, capital Y and capital Z. Substitute this value of psi equal to capital X, capital Y, capital Z in equation 12. That is, here we will have x, y, z, here we will have x, y, z, here we will have x, y, z, here also we will have x, y and z. Substituting this, we get something like this. Since the first term is differentiation with respect to x, y and z will be constant, it can be taken out. This is differentiation with respect to y, x and z will be constants. This is differentiation with respect to z, and x and y will be constants, which can be taken out. Here is taken out. Still, the first term depends on x, y and z. Second term depends upon y, x and z. Similarly, the third term depends on x, y and z. Now divide this equation 15 by capital X, capital Y, capital Z. If you do this, when you divide it by x, y, z will cancel out and we will have only capital X in the denominator. Here x, z will cancel out and we will have only capital Y in the denominator. Here x, y will cancel out and you will have only z, capital Z in the denominator. And here x, y and z will cancel out and we will have only e. And so what we will get is something like this. And if you look at the left hand side, first term depends only on x, there is nothing y or z. Second term depends only on y. Third term depends only on z. The term on the right hand side depends on x as well as y as well as z, and capital E can be written as equivalent to ex plus ey plus ez, and if you substitute it, we get something like this. First term on the left hand side depends only on x. First term on the right hand side depends only on x. These two can be equated. Second term on the left hand side depends only on y. Second term on the right hand side depends only on y. They can be equated. Third term on the left hand side depends only on z. Third term on the right hand side depends only on z. They can be equated and we'll get three equations like this. We can rearrange it in such a way that the coefficient of the differential term, dou square x by dou s square, is taken to the right hand side, and after that this whole negative term is taken to the left hand side. This will become positive and right hand side will become 0. If we do this for the other two equations involving y and z as well, we will get something like this. These three equations have to be solved. We will consider the solution of one equation, and there will be similar solution for the other two variables y and z. Now we are going to solve equation 21. Look at the left hand side. Look at the second term on the left hand side. Capital X is the function which has to be solved. Taking all the other things other than capital X, 8 pi square m ex by s square as k square. This can very well be taken as k square itself, it doesn't matter. What we are saying it is kx square because this depends on x. And substituting this in equation 21, we will get dou square s by dou a square plus k square x equal to 0. This is the standard form which has a solution. X is equal to a sin kxx plus b cos kxx. Now we have to apply the boundary conditions. Now let us consider the first boundary condition, and if you consider the first boundary condition, we will get when x is equal to 0, psi is equal to 0, and if we consider this condition, that is when x is equal to 0, psi is equal to 0, we will get when x is equal to 0, capital X is equal to 0, this is 0, this is 0, that is x is 0, and capital X is also 0. We get something like this, and 0 is 0, the whole term will become 0, cos 0 is 1, and this will become b, and b will be equal to 0. And substituting this in equation 25, second term will vanish, and we will get only the first term, that is x is equal to a sin kxx. Now we have to apply the second boundary condition, and if we apply the second boundary condition at x is equal to L, we get psi equal to 0. Psi, when we say x is equal to L, psi equal to 0, and the capital X will be equal to 0, and we get that when x is equal to Lx, capital X is equal to 0, this is Lx and this is 0, and this is true only when kx Lx is equal to nx pi, where n is equal to 0, 1, 2, 3, etc., and kx will be equal to nx pi by Lx, and substitute this in equation 27. Kx is equal to nx pi by Lx. We will get capital X is equal to a sin nx pi x by Lx, and now we have to find out the value of capital A. This is done by normalization. Remember that this is not L, this is Lx, and this is a function x, this is a function x, this is a variable x, small x is a variable, and this is equal to 1. Substitute the value of capital X, that is the value of the function capital X here, and we'll get something like this. And if you solve this, remember once again that this is Lx and not capital L, and we'll get A equal to root 2 by Lx, and substitute this value of A in this expression for capital X, that is equation 31. We'll get A is equal to root 2 by Lx, and if we do this, we'll get x is equal to root 2 by Lx sin nx pi x by Lx. And now if we solve the other two equations as well, which are mentioned here, that is one depending only on y and the other is depending only on z, and doing the subsequent normalization, this will become ky square, this will become ey, and here you will get kz square, and this will become ez, and if we solve for the value of x, y and z, we will get similar equations like this, that is y is equal to root 2 by ly sin ny pi y by ly, and z is equal to root 2 by lz sin nz pi z by lz. Now recall that value of psi is the product of x, y and z, and we have x given by equation 35 and y and z given by equation 36, and substitute this here, and we will get psi equal to root 2 by Lx sin nx pi x by Lx, root 2 by Ly sin ny pi y by Ly, and root 2 by Lz sin nz pi z by Lz. The first term is this term. This is root 2 by Ly sin ny pi y by Ly, and this is root 2 by Lz by sin nx nz pi z by Lz. That is the value of function capital Z. This is the Eigen function for the particle in a box in 3 dimensions. Recall k square is equal to 8 pi square m ex by s square. Rearranging this equation, we will get ex is equal to, take all the other terms to the other side, and we will get k s square by 8 pi square m. Recall that kx is equal to nx pi by Lx. This comes from kx Lx is equal to nx pi. So substitute this here. Instead of kx, we find nx pi by Lx. We find ex is equal to n square s square by 8m Lx square. And similarly, ey will be equal to ny square s square by 8m Ly square. And ez will be equal to nz square s square by 8m L square. And we know that E is equal to ex plus ey plus Ez. And substituting these two values, three values of ex, ey and Ez here, we'll get E is equal to this. And we find that s square by 8m is a common term in all these three, and this can be taken out, and we'll get s square by 8m into n square by L square plus ny square plus Ls square, nz square by Ls square. And for the cube, all the three sides are equal. Lx is equal to Ly is equal to Lz is equal to capital L, and so this will become L square, L square, L square, and this can also be taken out, and we will find s square by 8m L square is equal to n square plus ny square plus nz square, and nx, ny, nz take the values 1, 2, 3, etc. It will not take the value 0. And if you change the value of nx and y and z, the value of energy will also change. This is the expression for Eigen value of particle in a box in 3 dimensions. Now consider this table. Here we find nx is equal to 1, ny is equal to 1, nz is equal to 1. Consider this is 1 square, this is 1 square, this is 1 square, 1 square plus 1 square plus 1 square is 1 plus 1 plus 1. This is 3h square by 8ml square. We write this as E111. This represents nx is equal to 1, ny is equal to 1, nz is equal to 1. Next we consider 112. 1 square plus 1 square plus 2 square, because this is nz is 2, and we'll get 2 plus 4 equal to 6 square by, here get nx is equal to 1, ny is equal to 1, so 1 1, nz is equal to 2, 1 1 2. Now consider 1 2 1, that is nx is equal to 1, ny is equal to 2, nz is equal to 1. We'll get 1 square plus 2 square plus 1. This is once again 6 square by 8ml square, same as previous. So E112 and E121 are same. Similarly, when we consider 211, x is equal to 2 and y is equal to 1, and this is equal to 1, you get 2 square plus 1 square plus 1 square is once again 6 square by 8ml square. This we will call as E211. This is same as 121. 6 square by 8ml square, 6 square by 8ml square. These three are same. 112 is equal to 121 is equal to 211. Similarly, for 122, we will get this 1 square plus 2 square plus 2 square equal to 9 square by 8ml square. 212, 221, the same values. These three are degenerate levels, and this 222 is 2 square plus 2 square plus 2 square equal to 12 square by 8ml square. Now we will consider the energy level diagram. 111, the lowest energy. This is 3s square by 8ml square. 112, 121 and 211 have the same energy, and the degeneracy is equal to 3. There are the 3 levels have the same energy given by 6s square by 8ml square. Triply degenerate levels. Next is E221, 212 and 122. They have the same energy 9 square by 8ml square, which is higher than 6 square by 8ml square. 3 levels having the same energy, and so the degeneracy is 3, triply degenerate. There's only one level having the same energy, and so This is equivalent to degeneracy 1, which we normally don't specify. From the bottom to the top, the energy level increases. Thank you.